So we are going to start the session with Fenja Kollasch. She's a master student in applied computer science at the University of Heidelberg and a student researcher at the astroinformatics groups in HITS. And she's going to speak about the Explorer toolbox for exploration framework for big data set. So Fenja, the floor is yours.
Yeah, wonderful UTC morning to everybody. Yeah, I'm going to tell you about the idea of an explorer's toolbox, what all of you data adventurers need when you went through all the jungle that is currently very large due to the huge big data issues. Just a very quick reminder, I'm here at the Heidelberg Institute for Theoretical Studies with a very professional filming team. So everything you're seeing right now is streamed via cameras. I will not share my screen. Please don't force me to share my screen because this will probably cause to collapse everything. Yeah, I'm starting with a very basic issue, not even only in astronomy, but in all kinds of data sciences by now. The amounts of data that we are dealing with are getting larger and larger over time. And this is by far no new topic. And I think even alone in this week, you heard about this issue about 100 million times. Just to give you an idea about if this might be still something new for you, I displayed this table with data from 2017. Just to have a brief idea about how big the largest sky surveys are over there. And the data I display here is actually quite outdated. So by now we are not even dealing with terabytes and petabytes, we are dealing with larger spaces with zettabytes, and it's not going to be any better. It's getting worse and worse every day. There's getting more data. And this causes you as an innocent researcher to get lost in this whole forest of data point trees where no escape is for sure. So this is why machine learning became a huge trend in astronomy, in molecular biology, in basically all data sciences by now. We hope that our Lord and Savior machine learning will come to our rescue to help us to get an overview about all the data, to outsource tasks that are cumbersome to do and that are hard to do by hand if you're dealing with such large amounts of data over there. And this sounds very beautiful every time because it looks like, oh yeah, this is like I take my huge unstructured data, put it in and get my solutions out and get directly my research thesis and go to Stockholm to get the Nobel Prize because I made an awesome contribution to research. But the reality, as you might know, as everybody knows that worked with machine learning, looks a little bit different. It's not like you change your rusty bike into a fancy sports car and drive all the way to Stockholm. It's more like, okay, you start questioning yourself, what exactly do I want to show with my data? What do I want to do with my data? What am I looking for? Then you start extracting the appropriate data for this and fall into a whole pit of stones because you see this is very, very painful to get all these data. And if you finally got out of this pitfall, got all your data, you have to start cleaning. And this is what I introduced very briefly in the beginning. It's looking like you're in a giant forest with many, many trees, and you don't know which trees you want to cut down or something. If you have done this, you realize that all your nice cleaned data isn't compatible to the algorithms you want to use or to the programs you want to use. So you have to build a bridge to make data integration. What follows is a very, very awful journey across a stormy sea with a nutshell, sort of, because you see that the data has faults, that they are missing values, that you need to patch something up. And after you made feature engineering to actually made it at least a little bit usable, not only for you, but also for other people, you find out that all your models are completely garbage and you start to evaluate them. You have to crawl out of the last pit. But after that, you finally have a result. And yeah, this complicated journey, this rocky road that you have to go in machine learning is, for someone like me as a software developer, something that I think this is not okay. This makes this wonderful solution for the big data issue very unattractive for researchers that maybe are not familiar with computer science, that maybe are not programmers, that they just want to do their research. And they see this complicated road and think like, yeah, okay, whatever, I'm still doing this all by myself. I'm still doing this by hand because this is even easier than going this road over there. Like I said, this is where I want to come in to make this whole process at least a little bit easier for all of you, a little bit more usable. This is where software engineers speak about usability. We need usable machine learning programs. We need usable frameworks for you researchers to work efficiently. So how could such an exploration framework, such an exploration program with a nice usability look like? And to evaluate this, I want to talk a little bit with you about how we explore data and what are the important points from a software developer's point of view. So as I stressed out, we have to focus on the problem that we don't have to get our data explorers get lost in the data jungle. Basically, what they are doing is they perform distributed over many, many different types of data, many different data points like images, like curves, like tables, like plots, all over very different possibilities to visualize this data. But while they explore, they're basically performing the same actions. Yeah, you usually are browsing, you are scrolling through data, you are looking for something, you are filtering, you are doing different tasks for sure, and they have to be realized in different ways, but yet they are more or less the same tasks. And this is where software engineers are always like, yeah, nice, let's make a pipeline to organize these actions. The reality of this idea is perfectly described by this XKCD comic down below, because this usually looks like, hey, awesome, I made a wonderful automated data pipeline that processes everything automatically. And the reality is like, okay, this is a giant pile of random scripts that just explode if you input anything that's weird. So how can we solve this issue? How can we try to make a pipeline that will not explode if you do something unexpected at this point? And this is where I want to stress out that we have to keep pipelines, that we have to keep frameworks that want to make this easy for researchers more generic than by now. Now the state of the art is we have specific programs for specific issues that only work for this current issue and are completely going bonkers if you do anything with it that it was not meant to be for. Why do I think this could work? To display an abstract application is always a little bit difficult, but the two core aspects that influence the user experience during data exploration, these two aspects are very abstract, because this is, for once, visualization. Yeah, you need to have a visualization of your data. You need to see what you are looking for. Vision is the human's most strong sense. And you need to interact with this data. By the visualization, this is where we actually get to our first issue, more or less, because visualization is a very complicated process itself. This is why I displayed the visualization pipeline on top of this. So you almost halfway go through your data exploration just by finding an appropriate visualization. And this is leading to the fact that the applications are, again, very, very hard to make abstract, very much tailored to a specific problem. This is why I took the freedom to derive from the visualization pipeline a sort of exploration pipeline, where I think, yeah, of course, we need these points like pre-analysis, but we don't have to do the pre-analysis by ourselves. Let machine learning do the pre-analysis, but let the researcher decide which machine learning algorithm he wants to use for this. You need a mapping to a visualization, but let the researcher decide what kind of visualization this should be. And this is not the end of the road, by far not, because this is when the fun actually begins. Now you can efficiently explore your data, and this happens about interaction. So it's very important that we have a visualization that is interactable at this point, where you can click on the data, where you can enlarge, where you can zoom, all these things. And this is a process that repeats and repeats and repeats until a point where you finally found something that is interesting. To make this possible, we need abstract data types at this point, right? Because how you interact, this is definitely specific to your apparent problem, but that you have to interact, that is clear for all types of data and all types of explorations. So we need an abstract interface for these interactions and for the visualization. And why I believe this is working is because interaction is on a computer program that shows a visualization, nothing more than spatial transformations. And maybe you followed the talk that I gave, or the poster that I made 2 years ago, where I talked about spatial transformations in astronomy. This is something that is realizable in an abstract way. Just to give you an idea how such exploration frameworks look like, I present you very briefly 2 prototypes. The first one is the Megabus prototype to perform dimensionality reduction on spectral data in order to display them in 3D. So this happens by training an autoencoder, using the latent space of this autoencoder to be actually visualized. This looks like this. So in the diagram, you see the latent space of an autoencoder that was trained with spectral data. This is a very, very nice prototype developed by Antonio de Santos, who also works in my group. And if you now click at one of these points in the latent space sorted by similarity, you can see for once the prediction of the autoencoder itself, the reconstruction of the original spectrum, as well as the closest original spectrum that fits to this prototype at this point. Or maybe you remember the last ADAS in Groningen, where Bernd Doser and I presented pink and ultra pink, also 2 applications from our research group. So pink is an application where you also do dimensionality reduction with self-organizing coordinate maps, where the common shapes in the data set are represented by a certain number of prototypes. And I contributed a front end for this pink framework that you can actually see the prototypes, see the self-organizing maps, and interact with it. And this sort of looks like this. So here you see such a self-organizing map on the Radio Galaxy Zoo dataset, for example, with 4 times 4 neurons, 4 times 4 prototypes. And now you have the possibility to explore these prototypes, these representations of the common shapes in the dataset, click on them, zoom on them, select them, label them, even export them. You can have a view on the 10 best matching fits, so the real data, the best 10 real data points that fit to a certain prototype, for example, and many, many more things.
A couple of minutes more.
So thank you so much for that. I told you about generic frameworks in a very, very long monologue, and now I presented these 2 prototypes, and now evil tongues will say, yeah, these are not generic at all. These are specifically tailored, as you said, and you were talking about this is the problem. That's right. These 2 applications are still not abstract, but we hope to make them such a thing. We hope to combine not only UltraPink and Megabus, but there are so many interesting approaches to make frameworks for visualization and exploration. Alone in the last days, I saw very, very interesting presentations about pipelines and about frameworks. I saw even a very nice tutorial on Sunday from Peter Williams about exploring the WWT data. What we like to have is one framework working on abstract data types to be usable for all different kinds of data, that you don't have to reinvent the wheel all over the time again, that you really have a nice framework with a great usability that helps you to explore your data and don't lose the focus on your research by having to deal with annoying problems in the data processing. Thanks for the ability to talk over here. Hit me up on Discord if you have any questions, or maybe you even want to check out my GitHub repository. I would really like to say you were a great audience, but actually I have no idea. But at least I hope so. Thank you so much. And yeah.
Thanks a lot, Fenja. So yeah, I think we will, as you suggested, maybe if people have questions, I'll suggest they put them in Discord and then you can answer them directly. There are no direct questions now, and I think we should move to the next speaker. But thanks again, Fenja.